need to flash freeze some samples, but your lab's out of liquid nitrogen? Don't panic. You can still make a dry ice bath using dry ice and an alcohol like ethanol or isopropanol that will still do the trick, though it won't freeze your samples quite as quick as liquid nitrogen. It'll still have the effect of a flash freeze, preventing the formation of ice crystals, which is what we tried to do flash freezing for in the first place. So with liquid nitrogen, that's about minus 210 degrees Celsius, so it's going to freeze your samples really quickly. When we're talking about these ethanol dry ice mixtures, that's about minus 72 degrees Celsius with your ethanol and minus like 78 with your isopropanol or with acetone. And basically, so you're not going to get cooled as quickly, but it'll still be better than just sticking it in the minus 80. Basically, these alcohols are going to you're going to cool the alcohols with the dry ice, and they're going to cool to this temperature before which they would freeze. And so this is why you get a slightly lower temperature with the isopropanol than with the ethanol. It's because it has a lower freezing point. So what's going to happen is you're going to get these really cold alcohols, and now you stick your sample in there, and your sample is going to be hotter than the alcohol. So the alcohol is going to kind of like draw the heat out of your sample. What's really good about these alcohols is not only do they have that low freezing point, but they also have a high heat capacity. So they're good at kind of like taking a lot of heat without heating up too much themselves, because we don't want them to heat up and like boil and stuff like that. We want them or get hot and then not be cooling our sample. But these can have a high heat capacity. They can hold a lot of heat. They can take in a lot of heat without raising their temperature too much. And they're going to conduct that heat a lot better than if you were to just air. So this is a lot better than just sticking your sample in the minus 80. It's sticking it in this really cold liquid that can then pull things out. All you have to do is basically take some dry ice. It's best if you like crush it up a bit, pour on some of that alcohol. You want it to be really pure, or else you'll get some weird like jelly thing form, and then kind of wait for things to kind of equilibrate. If you're doing things in like chemistry, they have these fancy dancy containers to keep things like insulated and at a very stable temperature, and you have to do things more technically. But if you just want to flash freeze some samples, just take some container, make sure it's safe for something that's really cold. So either like if it's glass, make sure it's like Pyrex or something like that, or some sort of plastic container. Stick that dry ice, stick that alcohol, stick your sample in, and voila, you've got flash freezing. And remember that it's not going to freeze quite as quickly as liquid nitrogen, but it's still better than nothing, and it's way cheaper, and it's not just going to evaporate off on you right away. Of course, safety first. So you want to wear goggles as well as cryogenic gloves if you have them, so you protect your fingers. You don't want to get dry ice on you. You don't want to get splashing. So the splashing is going to be prevented by a bit by adding to the dry ice rather than adding the dry ice to it. But still be really careful and make sure you don't get that stuff on you, because freezer burn is really serious, like frostbite. We don't want that to happen. Also, be careful with your labeling, because these alcohols can take off like Sharpie. So use a solvent-resistant marker, or at least write on like the top of the tube or the part of it that's not actually going to go into the solvent solution.